Hello and welcome to this BioProcess International Ask the Expert webcast. I'm your host, Leah Rosen, the online editor for BioProcess International. Before we get started, just a couple of notes. This webcast is being recorded and will be made available for replay in the multimedia section of our website. We have muted the audio lines, but we welcome you to type in your questions for our speaker in the chat window on your screen. After the presentation, we will begin the question and answer portion, and I will ask our speaker your questions from the chat window. Your questions in the chat window will only be visible to myself and our speaker. So thank you for joining us today. It is now my pleasure to introduce our speaker, Matthew Smonskey from Thermo Fisher Scientific.
All right, thank you for that introduction. Again, I'm Matthew Smonskey, and I'm a senior scientist in the Gibco Custom Media Services team at Thermo Fisher Scientific. The goal of our group is to solve whatever bioproduction problems that you may have, whether that is creating a chemically defined media, increasing your endpoint titer, modifying protein quality attributes, or any other number of bioproduction relevant issues. In this talk, I'll be covering some of the concepts behind why these problems may arise and how a custom media using spent media analysis may be suitable for you. And I'll be covering that through a case study of a recent services project. So regarding those problems, frequently a culture may perform poorly or less than your overall goal. And this may be due in part to the fact that all moralized cell lines, including bioproduction cell lines, experience significant genetic and epigenetic drift throughout their entire course of use. This study on the right illustrates this point. This team in the Nicole Borth group sequenced CHO cells at every stage of their bioproduction life cycle. This included them as adherent cells, following adaptation to becoming not adherent over the course of a long-term culture, during batch culture, through adaptation to new components of media, and finally through clonal selection. In short, what they found is that during each one of these steps, evolutionary pressure is being applied to the cells, resulting in hundreds of thousands of small mutations, the middle section A, and thousands of larger structural variants, the bottom section B. And many of these are biologically active in the cells. The take-home message from this project was that while you may have two bioproduction cell banks expressing two molecules of interest from a common ancestral cell line, due to these mutations, the final cell lines are going to be very different, and this often manifests as having very unique nutritional requirements between the two cell lines. So now for the case study to illustrate this point. We took on a service project recently where the goal was to look at 3 catalog media and feed, compare the expression and overall performance to a competitor media and feed that the clients had been using with their unique cell line. And the work was divided into 2 major experiments. The first was a 14-day shake flask batch culture in CD CHO media. The goal here was to identify what media components were most heavily consumed in this very basic media, and therefore rate limiting to the overall performance of the culture. Data points that were collected were cell counts, viability, titer, glucose, and other major metabolites, and these were collected daily. We also performed spent media analysis for amino acids and select water-soluble vitamins throughout the course of the run. The second experiment was a 17-day Amber 15 batch-fed culture where we compared the 3 catalog media versus the competitor media that the client had been using. And the goal here now was to determine if our base formulation coupled with a feeding strategy were sufficient to meet this cell's unique nutritional requirements. And the data points that were collected were all the same. And here I'd like to stress that we did not perform any process optimization or formulation optimization. These were strictly our catalog media with a basic feed strategy that we had been using. So here are the results for that first experiment. Most of this is rather straightforward, so I'd just like to highlight a few of the important details. So first, in panel A, this represents the viable cell density of the culture. Here we only achieved a peak VCD on day 3, and it was rather low, only approaching 1.5 million cells per ml. And this is suggestive that some critical component was exhausted in the media at this point, limiting growth. Spent media analysis would hopefully identify this because, as you can see in panel D and E, while glucose and glutamine were indeed exhausted, they didn't reach 0 until well after the peak VCD. So we do not believe these to be the major rate limiting factors in the culture. Panel F illustrates another potential major issue in the culture, and that is the high ammonia that is being produced. We can see that it is reaching approximately 10 millimole per liter. And this is a level in which we would expect to see a negative impact on culture by the ammonia alone. And hopefully this would be another issue that we could address through spent media analysis. So here are the results of that spent media analysis, where we look at a time course of the culture and look to see if the concentration of the aminos and vitamins in culture correlate to the raw data that we saw in the previous slide. The critical ones here that I'd like to focus on first are the essential amino acids. These are the amino acids that cannot be biosynthesized by mammalian cells. They must be provided to the cells via a media. The non-essential ones can be synthesized by the cells, and they are still considered in our analysis, but in some ways they are less critical than the essentials. So when we look at the data, we can see that cysteine is exhausted in these data by day 3, and this directly correlates with the peak VCD observed on day 3. And since this is one of the essential amino acids, this is strongly suggestive that this is the cause of the poor growth. And I'd like to point out that there is a limitation to our cysteine spent media assay. We cannot precisely quantitate the concentration as it correlates with other forms, but we can determine whether it is present or not. And here we can see that it is definitely not by day 3. The other major observation here is the exhaustion of asparagine, which once again closely correlates with a high ammonia being produced. And this is likely due to the asparagine deamidating to form ammonia. Also of note, we can see that ethanolamine is exhausted, but this now is one of those non-essentials. This is not likely to be critical as it can be biosynthesized by serine. And we can see that the data here, that serine is strongly consumed, supporting this idea. And finally, we do see that thymine is depleted by day 6. This is another essential component. So we'll need to keep an eye on all of these components as we proceed into the next experiment. So here we now move into the amber, where we were comparing our catalog media and feed versus the competitor media and feed that they had been using. Again, I'll just focus on a few panels here. In panel A, we can see that all of our catalog media and feed supported a higher viable cell density, above 15 million compared to the competitor media, which was only approximately 10. And since this was a fed batch culture, peak VCD was achieved now on days 7 and 8. Similarly, in panel C, we can see that all of our media resulted in a higher titer compared to the competitor media. Ultimately, on day 17, titer was a 50% increase in our top performer, which is QP-CHO, a new media that will be launching in early 2019 over the competitor media. And again, in panel F, we can see very high ammonia being produced, especially in our conditions. So here I'll be just presenting the spent media for our lead performer in the interest of time, but I would note that we did also perform spent media analysis on the competitor media, and I identified that cysteine was once again exhausted, correlating to the peak VCD. But here now, we can see that cysteine in our cultures is maintained throughout the course of the run. So now that we have identified and solved through a feeding strategy what that first rate limiting step was, we can now look at what that potential second level limiting factor may be. And the data strongly suggests that it's thymine, which is being depleted around or at the same point of the peak VCD. Again, this vitamin is critical as it has a derivative that is responsible for the catabolism of sugars and aminos. And it appears that we simply are not delivering the vitamin sufficiently to meet the biological demands of the culture. And as before, we can see that asparagine is being rapidly consumed as quickly as it is being fed to the culture, driving this runaway ammonia that's being observed. As for the rest, again, we aren't overly concerned with ethanolamine here, as it can, again, be biosynthesized by serine, and we can see that our feed strategy is delivering sufficient levels of serine. And lastly, we can see that we aren't seeing major accumulation of any other component in the spent media that may be reaching a toxic level in the cells. So to summarize these results, during the first experiment, we were able to identify what the likely critical components may be that can result in a limited performance in overall culture. The second experiment, looking at our catalog media, resulted in a significant increase in viable cell density over the competitors. as well as a 50% increase in titer. And again, here I would like to emphasize that these nice successes were achieved with no optimization whatsoever. So following those wins, we were able to characterize a bit better of what was happening in the culture via spent media. And again, the data strongly suggests that thymine is the current major limiting factor in the culture, limiting overall growth and performance. Furthermore, very high levels of ammonia may be limiting performance as well through the very rapid consumption of asparagine. So now, armed with that information, we can generate several recommendations on how to potentially further improve overall performance. First, we'd suggest a thymine supplementation or a custom formulation to deliver higher concentrations to the culture to determine empirically if this is in fact that second level limiting factor. Next, we'd suggest lowering the asparagine exposure to the cells, either through process optimizations or more likely through a custom formulation. And this is a very feasible strategy as, again, asparagine is not one of the essential aminos. The cells can synthesize it itself using pyruvate. And this would ideally lower the overall ammonia being produced, improving the overall health of the culture. So that concludes this simple case study. But I think it's fairly illustrative of the issues that bioproduction cultures can face. Another CHO cell line is likely to have its own very unique set of nutritional requirements, and these can be addressed through custom formulations powered by spent media analysis. So with the last couple slides, I'd like to detail the custom services that we offer. First, I'll briefly cover the media analytical services. And these can perform the analysis that I had just discussed. And these are performed using our suite of UHPLC, HPLC, and ICP-MS equipment, where we can quantitate amino acids and vitamins as well as many other trace elements that I didn't discuss in this talk. Our turnaround time for aminos and vitamins is very quick at only 10 business days. And finally, we have facilities in the United States and upstate New York, where I'm located, as well as Scotland and China to meet whatever your specific needs may be. And we have promotional offers around these services. So following this talk, we'll be having an email sent out that will provide further information about that. And finally, this slide covers the width and breadth of our custom service offerings. In short, we have services that can help bioproduction clients at every step of the way. This includes the earliest stages of cell line development and clone selection, to media development and process optimization, to scaling up to a prototype media with support provided to the client for in-house evaluation, to troubleshooting throughout the course of your commercialization. So with that concludes my talk. And before questions, I'd like to acknowledge the people who helped contribute to all of this. First, Gino Stoffa and I were the two lead scientists for the case study that I outlined. And I would absolutely love to thank the analytical team members who directly helped to generate the spent media analysis. And that would be team lead of Jamie Goldfuss and two great chemists, Carolyn Shillelagh and Bob Martin. So again, thank you. And at this time, I would welcome any questions that you may have.
Great, thanks, Matthew. So the first question is, you only described amino acids and vitamins in your analysis. What are the other testable media components, and how might they impact the culture?
Right, good question. So I did just mention the aminos and vitamins here. In many ways, these are the very good low-hanging fruit in culture. They are very easily tested, very easily supplemented in culture or through a custom formulation removed, again, to address restrictions on growth or runaway issues like ammonia. But you do rightfully point out that there are many other components in media, and those extend to, for instance, trace metals. I briefly outlined our capabilities of looking at those. Those, again, can have a major impact in a culture, be that overall health of culture, for instance, lactate production. It can also impact protein quality, for instance, and overall growth factors. So we can look at that. That will be incorporated as well. That's also something very interesting to look at if you have potential concern for trace metal contamination. For instance, if you have a dry powder media and you're resuspending it in a different water supply, a small amount of a different trace metal can have a major impact in culture. So we can investigate that. And then even beyond all that, our analytical services have the capability to analyze glutamax, polyamines, pluronic, cholesterol, select fatty acids, peptides, proteins like insulin, BSA, transferrin, EGF. And then, like I indicated before, we can even look at protein quality attributes like charge variance and glycan profiling.
Okay, great. What days should you sample your cultures for spent media? Should you pull terminal samples?
Good question. So we've had instances where people have submitted terminal samples. So for instance, if you have a 14-day run, people will just submit day 14 samples. That's really not going to be all that informative, as feeding strategy will be continuing through the culture. You'll have cells dying, so you'll have components accumulating over time. It's really not going to be that informative to the overall culture. So I would strongly recommend having good coverage throughout the run, like my example showed. So first, I would say if you are beginning feeding, say on day 3 for instance, I would have the first spent media sample pulled prior to your first feed so that you can look at how the base formulation supported growth from inoculation to your first feed. If it showed some critical component was exhausted, you would maybe have to change your feeding strategy, for instance, or create a more fortified base formulation. And then I would like to have good coverage through your exponential growth to make sure you're not limiting prematurely overall biomass in culture by withholding some amino acids. So good coverage through the exponential growth. And then some level of coverage also through when they plateau and enter into the productivity phase. Again, you would want to make sure that you are providing the necessary building blocks to make your protein of interest, your antibody for instance, make sure that you're delivering all the aminos that are required for that.
And is there a benefit of pulling samples multiple times a day or just once per day for testing?
Typically, I think once per day would be sufficient, but again, we're dealing with a biological sample or a system here. Your samples may be very different. It's dependent probably on your feeding strategy. So you would have to probably take all that into account. But for a traditional fed batch approach where you are maybe feeding once a day or every other day, I think a 1 per day sampling would most likely be sufficient.
Okay. And how is the scalability of the result? Do you expect the same consumption trend in bioreactors as in a shake flask or Amber 15?
So that's entering into a lot of questions that are very persistent in scalability in general. I think we do a lot of work at the small scale for custom formulations. And in general, I think you would be able to see large trends in the data at a small scale. And it should hold fairly well going up, but you would absolutely, I think, still need to confirm that at a scale up.
Okay. So this is the last question. If we haven't gotten to your question, we'll be passing those along to Matthew and he can follow up directly. So is a lactate accumulation still considered as a primary impediment to MAB production like ammonia? And what principal approach would you take to minimize lactate accumulation?
Yeah, so again, we definitely see some cell lines much more susceptible to lactate, but in general, yes, we definitely do consider that still a major issue. They do like lactate to an extent, so we probably don't want to abrogate lactate consumption entirely, but you want to maintain it at certain levels. So that is something that we can address through spent media analysis and custom formulations. Of course, there's always this strategy of tightly controlling glucose addition to the cultures, but that is another component that we do, or an issue that we do address during custom media through formulation changes to trace metals, for instance. And those can have major impact in lactate production as well as the switch over into lactate consumption.
Okay, great. So thank you, Matt, and thanks to our audience for joining us.
Yes, thank you, everyone.
The recorded version of this webcast will be available for on-demand viewing on our website as a registered attendee. You'll receive a follow-up email providing you with a direct link. We look forward to having you join us at future BioProcess International Ask the Expert webcasts. Look for those announcements in your inbox. Thanks and have a great day. Goodbye.